Hello, and welcome to EC2 birthday of 15 years. My name is James Wenzel, and I am a Senior Solutions Architect. I work on the ELB service team, and I'm here today to talk to you about connecting your network to AWS with hybrid connectivity solutions. To do this, I'm going to have to go over a couple of things that you may already know about, such as Transit Gateway and PrivateLink, and show you how they work to actually connect your on-premises or your remote premises to AWS. So let's talk a little bit about AWS and about our whole hybrid strategy and hybrid world. If we look at Gartner, they say about 88% of enterprises have a cloud-first strategy. But within that, 86% still need to maintain some sort of infrastructure on premises. And there's many reasons for that. There may be things that you simply can't move, like for instance, if you're in an auto manufacturing plant, or if you have something that needs to reside on site because of security or some attestation of security that you need to prove that you can't move that data into the cloud. So to do that, we have a couple of vehicles. We're going to talk about 3 of them and then add on some others and then show some reference architectures. So some of these may be familiar, some of them may be new, but we have our client VPN. This allows you to connect your remote users to AWS and access various functions and even the internet. We have AWS Site-to-Site VPN, and there's a lot of different iterations of that you can use depending on your use case and your business needs. And we have AWS Direct Connect. And Direct Connect is a methodology of connecting directly to AWS through a partner. And those can also come in a couple of different forms. We'll dive into those. But first, let's dive into Client VPN. This is probably going to be the easiest and most simple one we can cover right out of the gate. So for Client VPN, we will start out with our VPC, which is what you want to connect to or communicate with. And then you have your endpoint, which is like a ENI or a network interface with an IP address that you will attach. So the client will use an open VPN client or user, will connect to that endpoint, and that endpoint connects to your VPC. We use a TLS-based tunnel, and this goes over the open internet. So there's nothing else special that you need other than some form of an internet connection. Then from there, you do an attachment to the VPC, and then that will allow your user to actually connect up to other VPCs if you have things like peering or transit gateways, or you can also connect to your public services and even the internet. Some users also use this as a way to get to on-prem in another location. So for instance, if a user is sitting in an office, they can connect up to your VPC, and then they can go ahead, if you have, say, Direct Connect or a Site-to-Site VPN, and use that same connection, if you allow them to go ahead and connect back to your on-prem in another location. The thing that's important to note is that there's a lot of security profiles and security you can put around this type of connection. So it is not once you connect, you have access to everything. You need to have a strategy and a policy set in place to make sure that the users, your end users, your clients, can connect up to what you need to, and they can communicate to what they need to communicate to when you want them to, and for how long you want them to. So this is one of the more simple use cases that we have to connect remote users to AWS. The next thing we're going to talk about is VPN site-to-site. VPN site-to-site model, again, we start out with our VPC, the thing we want to connect to, our virtual private cloud. This is what runs all of our workloads. And then we'll have some form of on-prem. The VPC will have a VGW, or a virtual gateway, which will allow your tunnels or your VPNs to communicate or connect to. And our customer gateway, this is the piece of equipment that you have that will initiate the connection, sits on your on-premises. Now, of course, this goes over the internet, so it requires some form of internet access. And then you will establish a pair of tunnels. The first tunnel that you establish is a 1.25 gigabit tunnel, and that will be your primary communication path. And then, of course, because we always go by the line, everything fails all the time, we want to make sure that we have some form of redundancy. So we have a second tunnel. Now, both tunnels are initiated in the communication, but you can only communicate over one tunnel. ECMP is not supported here. So your throughput speed essentially will be 1.25 gig from the on-prem in this scenario over to the VPC. And then, of course, our IPsec tunnel will go ahead and communicate directly over the internet. So the second thing that we can add to this is another form of connection methodology. And that connection methodology is a transit gateway. The Transit Gateway is like a central spoke or a central hub for a hub and spoke technology or methodology for communicating and connecting up all of your VPCs. We'll go a little bit into how this works for the Transit Gateway in a little bit in this presentation. But in essence, it allows you to connect up to 5,000 VPCs in this manner. The cool thing is now you're centralizing your communications path from your VPN to the Transit Gateway. Another cool thing about the Transit Gateway that we like is that it can actually connect up to 50 tunnels, each of them at 1.25 gig, and you can use ECMP, or equal cost multipath, to actually combine the bandwidth of that tunneling up to 50 gigs burstable. So it can actually definitely increase your throughput and your usability, as well as give you central access connectivity to the rest of your workloads. Now, of course, the thing that we can't control is the internet. So one of the things that we have done is we've used our gateway or our global accelerator to be able to help us accelerate our VPNs. Now, how do we do this? Around the globe, we have points of presence, or POPs, that have connectivity to the global accelerator. And the global accelerator then, in essence, moves the connectivity closer to where your on-prem is. This way, you take more advantage of the AWS backbone than you would before, because you would basically have to rely on what we call internet weather. So what is this internet weather? Well, internet weather is basically your applications are communicating over the internet. And when you take a specific path to the internet, it may not necessarily be the same path that you initiate that is the same return. So this can introduce a couple of different problems. There could be latencies in the return path or latencies in the initial path, and there could be issues along the way that will cause rerouting. So this does not necessarily give a assurance or a reliable connectivity piece that you can rely on right down to the latency, millisecond, all of those things, if that's your concern. So why would we want to move closer to the AWS backbone? Well, let's talk about the AWS backbone. The AWS backbone is basically fiber and connectivity across the globe to every AWS region and to AWS POPs. And all of that connectivity is under the control of AWS. We don't use third-party people to actually carry things over our lines. We do have fiber that goes underneath or in the Pacific and the Atlantic, and we monitor and control all of those lines. And they are basically at a redundant 100 gigabit E network. We always understand what the capacity is of this network, and we always keep improving and adding the capacity as our customers and anybody else uses this network to keep ahead of any issues that may arise in case if there's not enough bandwidth or any slowdown. Our points of presence are located around the globe, and they are under our control. And those points of presence is what I was talking about for Global Accelerator, give us the ability to get the workloads closer and closer to you. Now, what does this global backbone support? It supports right now, as of this recording, 25 regions, 81 availability zones, 7 local zones, which are basically a presence in a major metropolitan area to reduce latency to that area, such as LA. 14th wavelength zones, and the wavelength zones are accessed from 5G networks or telco networks from your cell phone directly into AWS. 108 Direct Connect locations, and we'll talk about Direct Connect a little bit more, and then back to that 230 plus points of presence. Now, we're always improving this network, and we're always trying to do our best to make it better and better. So by the time you watch this video, or by the time you watch this Twitch stream, it may have actually changed. So always make sure that you keep well informed of what's going on here. The next thing we're going to talk about is Direct Connect. Now, Direct Connect is fairly unique in the fact that it requires a partner of AWS to help you out gain connectivity. The way it works is a very, very high level is you would go on the console and you would want to purchase a port or a speed from Direct Connect. You want to figure out whether you want to do a dedicated connection or if you want to do a hosted connection. A dedicated connection, you purchase the port directly through AWS, and it could be 1, 10, or 100 gigs. Then from there, you would need to pick out a partner to carry the line from where AWS's port or equipment is in the region you want back to your data center. And if you're in a hosted scenario, the hosted scenario would go to the partner portal, and you would ask the partner to set this up for you, and they would put a connection piece into your account called a virtual interface. So what kind of virtual interfaces can you have? So there's 3 different types. There is a private virtual interface, and the private virtual interface will allow you to connect up through a Direct Connect gateway up to 10 VPCs. When you order a private virtual interface, the number varies depending on the type of connection you order. If you're ordering a dedicated connection, you get 50. They could also be converted to public VIFs, which you see here on this table. If you're ordering something like a hosted connection, you'll get 1. That's important to note, and we'll talk about that in a little bit. The second type, and you get a single one for every physical connection, is a transit virtual interface. The transit virtual interface also lands on a Direct Connect gateway. Now, to talk a little bit about a Direct Connect gateway, what that is it's a global construct, which is free, that will take your connectivity, up to 30 of them, so up to 30 private VIFs or up to 30 transit VIFs, and allow you to go ahead and communicate and connect around the globe to any region, as well as to multiple accounts. The one thing to note is if you put a private virtual interface on a Direct Connect gateway, it changes the Direct Connect gateway to only accept private VIFs, and it will give out the 10 private VIFs that can connect up to 10 VPCs. If you put a transit VIF on there, the thing that actually connects you to a transit gateway, it will change it so it can only accept transit VIFs. And from there, you can connect up to 3 transit gateways around the globe. And then the last one is a public VIF, or a public virtual interface. You can have 50 of these, or again, they can convert to a private VIF. So if you had 25 private VIFs and you're using 25, then you could also use another 25 public VIFs, but you can't use both at the same time, so it's not 100 VIFs. The public VIFs will allow you to connect up to our public services, such as S3, DynamoDB, and CloudWatch, things of that nature. This will give you a dedicated connection and dedicated speed through whatever you chose for Direct Connect, so that you can actually interact with those public services on a faster basis than relying on the internet. Another thing to note about virtual interfaces is they do increase per line. One of the things that you can do with your Direct Connect is you can create a link aggregation group, or a lag. So you can order, in the case of 100 gig, up to 2 in a lag, which effectively will give you 100 private or public VIFs. But within that lag, you still only get 1 transit VIF. And then the other option for the 1 gig and 10 gig connections is you can have up to 4 physical connections. And of course, with 4 physical connections, that will give you 200 options for public or private VIF, but still only 1 transit VIF. A transit VIF follows a physical connection, or a single connection, and it does not multiply. So again, you heard me talk about things like dedicated, and you heard me talk about things like hosted. So dedicated, you have 1, 10, or 100 gigs, you manage the port, and you work with the provider using something that we call an LOA CFA, or a certificate of authority, that you would get from AWS when you order the service, that would show the provider or the partner that you chose how to connect up the equipment from AWS to your equipment. We'll go into that in a little bit more detail. Now, to talk about the virtual interface for the hosted connections, where you only get 1, the benefit with this is the partner pretty much manages the connection for you and places the virtual interface into your account. Now, the reason why we talked about the Direct Connect gateway was because of the fact that you can take that single VIF, if it's a single private VIF, you can break it out to 10 private VIFs for your connectivity. If it's a single transit VIF, you can land it on a Direct Connect gateway and again, connect up to 3 transit gateways. One thing to note that's important about a Direct Connect gateway as well is that it does not route itself. It is a reflector of routes. It doesn't actually do the routing. We'll explain that in a little bit. The other benefit too for a hosted connection is that you can have different connectivity speeds. You'll note that in the dedicated connection, as I mentioned before, you can have 1, 10, or 100 gigs. But with a hosted connection, you can go from 50 megs all the way up to 10 gigs. There's a lot of times when our customers do not need to have even 1 gig of connectivity, or it's not even possible within the geolocation area that they have for a partner to provide that. So we offer for this connectivity for our partners so that you can have the connectivity speed that you need. So let's break down Direct Connect and see how it actually works. We always start with our on-prem, because that's the main point for hybrid in this whole conversation, right? Is to talk about connecting your on-prem to AWS. Then we'll have our region and our VPC and our workloads inside that. Now, the service provider network is the network that your partner provides. So this is their fiber, their lease line, their local loops that will actually get you connected to what they need. Then there will be a Direct Connect location, or a Meet Me location as it's sometimes called. And in that Meet Me location, there will be an AWS cage where we have equipment where we control, and then there will be a customer cage. That's the equipment that is under your control as a customer. Now, this equipment could also be leased or under the control of the partner that you choose, or the service provider that you choose, but that's between you and the service provider. What they're going to do is they'll set up the cross connect and then basically allow for those virtual interfaces to connect to your workload. In this instance, we're using a private virtual interface and we're connecting to a VGW to our VPC. Now, of course, I mentioned that you can also have a public virtual interface. So in this scenario now, we have our public virtual interface that is allowing us to get to S3 and Lambda and DynamoDB at the speeds that we need, as well as our private VIF, which is allowing us to contact and connect our internal workloads. So what if we wanted to add another VPC? Remember, you can again go ahead and add another VGW to a separate VPC, leverage the same line, and then have connectivity to that VPC. Now, these two VPCs are not connected right now in this diagram to each other, so they cannot speak back and forth unless they do something like a hairpin or a trombone to your internal network. You could use peering or a transit gateway as well to facilitate communications between those VPCs, but then you need to be careful of the routing you set up within the VPC routing tables, as well as the customer provided equipment or your equipment on your end to make sure everything can communicate effectively. So the Direct Connect gateway, remember in the hosted scenario, you only get one, but you can also use this in a dedicated scenario, will allow you to break out your connections. So in this scenario, our private VIF lands onto our Direct Connect gateway, and because the Direct Connect gateway can connect up to 10 other VPCs on the private, because remember, if you land a private VIF on a Direct Connect gateway, it turns it into pretty much a private Direct Connect gateway, and a TVIF on a Direct Connect gateway turns it into a Transit Gateway Direct Connect gateway. This scenario is allowing us to communicate up to 10 VPCs because of a private VIF. So let's talk about Transit Gateway for a little bit before we get into how we connect and use a Transit Gateway. Our Transit Gateway allows us to actually become, as I mentioned, the central hub and spoke of all of our communication paths within AWS. Transit gateways can actually be peered to one another across regions, but in general, a single transit gateway can be considered a regional construct. In the Transit Gateway, you have three main pieces that allow you to facilitate communications. You have your associations, your propagations, and your routes. In this example, we have an on-prem that's connecting up to our Transit Gateway. This on-prem is going to go through a Direct Connect gateway. It's using Direct Connect and going to the central core of our cloud network. So communication is facilitated by the fact that all of our different VPCs are defaulting to the Transit Gateway and its routing table to decide who can go where. In this example, our front end, API layer, and DB layer can communicate freely back and forth between each other as well as our on-premises. You will note, though, that in the front end, we do have some special considerations because there's another route option. That other route option is the Internet Gateway. And in there, on the subnet, we have a default route to the IGW, to the internet, and then anything internally to our internal network, if we pretend that our on-prem network as well as our cloud network are all 10 within the Slack 10/8, it will send it through to the Transit Gateway to make a decision as to where the routes go. A couple of considerations for Transit Gateway networks. They can connect up, as I mentioned, to 5,000 VPCs. There can be 5 transit gateways per region per account. This is a soft limit. If you need it increased, please talk to your account team and let them know why. It can be peered to up to 50 other transit gateways in other regions. This allows you to build a full mesh network. And if you think about 50 times 5,000, that gives you quite a footprint that you can connect to. Each of them can support up to 10,000 routes and has the ability to start with 20 routing tables. Because remember, every association can only be done once, but your propagations can happen multiple times. So you want to have a good routing strategy as to how you want your packets to flow when you're setting up a transit gateway. I also mentioned before that it will support a 50 gig burstable ECMP 1.25 gig VPN tunneling system. I know that was a lot, but each tunnel is 1.25 gigs. You can have, I think that's up to 40 of them. That gives you about 50 gigs burstable. They don't have to all go to the same location. You can chop that bandwidth up and send it to different locations. It also supports something called GRE, or generic tunnel, through the Transit Gateway Connect attachments. And there's a maximum of 4 of those, and we'll talk about that in a little bit. And then, of course, Direct Connect can have up to 30 transit gateways connected to it. So there's quite a lot of things that Transit Gateway gives us as a central connectivity piece when we want to connect back to our on-premises. Now, as I'm mentioning Transit Gateway, there's a couple of things that are pretty cool with Transit Gateway Connect. Transit Gateway Connect is actually a methodology of connecting your on-premises networks through something called an SD-WAN, or software-defined WAN, to your AWS regions. So when you have something like an SD-WAN, you might have different connectivity models to get into AWS. Some of them being the Site-to-Site VPN, those could be remote sites, and another one could be Direct Connect to main sites. You can filter and funnel all of them through in a connection strategy to AWS. Transit Gateway Connect will help you with the routing, adds, moves, and change updates from all of your VPNs to your infrastructure on AWS in a couple of cool different ways. One thing to note, though, is when you're using Transit Gateway Connect, one thing is different than using the standard VPN connectivity methodology. The standard VPN methodology is 1.25 gig, whereas the connection tunnels for Transit Gateway Connect are 5 gig, effectively allowing you to push more data through the Transit Gateway connection. So let's see how we set this up. So you have your Transit Gateway Connect, and your Transit Gateway is connected to a couple of VPCs. You have your different branch offices that want to connect, and what you need to do is you would need to set up your SD-WAN VPC, or software-defined WAN VPC. In there, you'll have something that runs some form of appliance on EC2 that handles all of your SD-WAN connections. This could be a vendor solution, this could be your internal custom solution. And then, of course, you have your internet gateway that facilitates communication via the VPN to all of the other branch locations. When you communicate or set up this connection, you will then go ahead and make an attachment to your Transit Gateway, effectively allowing it to become part of the routing system of all of the rest of your workloads. Now, the interesting piece is when you set up the GRE tunnel, or the Generic Routing Encapsulation Tunnel. See, I got it right this time because it's up there. And this GRE tunnel will actually allow you to pass routing information back and forth to the Transit Gateway, so that if a branch office comes on or offline, say if it's a point of sale location or store location, you don't have to make entries in all of your constructs and all of your networking constructs every single time. The routing from BGP will go ahead and pick that up and make those changes that you've defined for you. Now, I mentioned before about accelerated VPN, and I showed about Global Accelerator and how that it moves the connectivity closer to your customers. So we're going to dig in a little bit and discuss how all of that looks and how all of that works. So let's start out by just going through an understanding that if you put something out for the internet to be able to access, it has a global presence. So if you're in one location, like US East 1, everyone from around the globe has the potential of actually connecting up to that workload, or connecting up to your offering. The one thing we do know, however, is that depending on where you are and how far away you are, you will still be subject to what we discussed before as internet weather. So everyone may not have the same experience. So as I mentioned, we wanted to put points of presence around the globe in areas where we do and do not have regions, so it gets your workloads closer to your customer and get them on that backbone, that dual 100 gigabit backbone that I was talking about, and get them through to your workloads as fast as possible. So in essence, we will start with having our local ISP or whatever the customer is connecting through to get to the internet, and we will do our best to move the location of where they connect up to the backbone, which point of presence detects that they will have the lowest latency to go ahead and start communicating with your workloads. This should decrease the time for connectivity, the path you go through the internet, and it should decrease your latencies to allow your customers to have a better experience. But that's not the only thing it's good for. The other thing that you can do is you can go ahead and use this for a globally redundant or reachability of your workloads, so that when you have something that's being offered, say in this example here in the Americas, in Europe, and in Eurasia or the APAC area, all of your workloads will be able to be available, but it won't be something where you have to do switching between each one. The way we do that is we have our edge locations, which are aware of all of your workloads and which are aware of each other. And then we set up our global accelerator to go ahead and create an endpoint group or a connection to the load balancer, or the, in this case, ALB in endpoint group 1. And then we have an ALB in EUS2. And then we'll have another one in our AP Southeast. Now, all of these are part of the global accelerator. And when there's a communication path between your customer to your workload, if somebody is closer to the AP Southeast, they'll go ahead and route to that workload that is closer. All of these things you have control over with a lot of weights and dials, where you can determine which region gets preferred traffic, as well as even down to inside your VPCs and your workloads, which load balancer actually gets the most traffic. The other cool thing that we can do with Global Accelerator is we give you a pair of anycast IP addresses that do not change. So for all of these IP addresses, we have a primary and a secondary. Remember, we always go under everything fails all the time, so we always want to make sure that we give a pair of IP addresses. Each IP address is actually connected to a different logical set of, or physical set of the points of presence, so that if there's a failure within the point of presence, there is an alternate or a backup path. Now, all of the endpoints, which are aware of the IP addresses, the anycast pair that's been given to your global accelerator, and they will advertise them out as exactly the same using anycast, so that someone can communicate to your workload either in our US East 1 or our EP South 1 using the same pair of IP addresses. It would be recommended to put that pair into DNS or Route 53 so that you'd have the primary and secondary in case there's an issue. The other thing that's pretty cool about Global Accelerator is that it will inherit the health checking of all of the load balancers that are part of its endpoint groups. So if you have an endpoint group that actually goes down for whatever reason, or the load balancer itself is detecting no healthy targets, it will not be a part of the routing. So if there is actually something like a failure that happens, like we have over here in our secondary group in EU West 1, the Global Accelerator will help reroute traffic from the closest endpoint to the closest part of your workload. The other thing you can do too is you can use this for adds, moves, and changes. So in this example, let's say we're bringing up another VPC and then possibly retiring the old one. We have to make changes, we're changing IP addresses. There could be many reasons why we want to do that. We can use the weights and dials to basically ratchet up the traffic to that new VPC and cool off the traffic from the older VPC. You can also use this in different types of deployment methodologies for testing if things are going well by sending a small percentage of traffic and then increasing that traffic more and more and more until it's at the acceptable levels. The other thing that's pretty cool about Global Accelerator is it's protected by Shield. Shield is a free offering that we have that uses a way of different methodologies, AI, ML, and a bunch of technologies we put together, as well as human technology, people, to detect and safeguard against layer 3 and layer 4 DDoS attacks or distributed DOS attacks. So anytime someone is actually communicating with your workloads, you'll have good actors and bad actors. And what we try to do is filter out all of the bad actors and then send that traffic that is required, or the good actors, directly to the destination where it needs to go, and filtering out all the bad actors. This does a couple of things. Of course, it helps out in your security stance, which we always want to make sure that you're as secure as possible. as well as it helps out where it doesn't clog your lines. And of course, you can stay up so you won't be taken out with an outage. So if we want to look at our previous example where we were looking at our transit gateways, and we had some ELBs, or elastic load balancers, in our front ends, we can go ahead and set up our global accelerator. Our edge locations will be located closer to our customers throughout US East 1 and AP East 1 in this example. And then those pair of IP addresses, I'm only putting the first of the pair, but it would be both sets that would be represented around the globe. Our users would then be able to interface with those no matter where they are and send traffic, and then everything should flow just fine. So when we think of hybrid connectivity, we've mentioned Transit Gateway as being something that's a cloud construct that facilitates it. We've also have something else too that you may not think of as a hybrid kind of space, and that would be PrivateLink. So let's talk about PrivateLink for a minute. PrivateLink will allow you to have a couple of endpoints, or ENIs, elastic network interfaces, that take a local address from the subnet that they're placed in your workload, and you would work back and forth with that ENI to gain access to a service, and it would look like it's local to your workload. So let's see how that looks like in the different points or different types that we have. So we have two types of PrivateLink endpoints, and it's important to understand them because one will facilitate hybrid connectivity and the other one will not. The one that does not facilitate hybrid connectivity is the gateway endpoint. And the gateway endpoint allows you to gain access to public services through your local VPC routing table. The nice thing about this is that all traffic stays on the AWS backbone, nothing is exposed to the internet, and all you have to do is turn it on. There's not any major changes to your applications or any flows within that VPC that you have to change to take advantage of this. Many, many benefits to this too. Of course, going through backbone speeds, not relying on internet weather, going out the IGW to get to public services, security, you can set policies on these endpoints. There's many, many reasons why this is a good idea. The second form, and this is the one that can enable hybrid, which I'll explain in a little bit, is the interface endpoint. And again, this is the elastic network interface, or ENI, that basically connects to your local workloads and facilitates routing back and forth between public services or other services and your local workload. So you would basically get 10.1.2.5 in this example as a routable IP address that you can use for connectivity. So the way to take advantage of that is if we have a provider that basically is providing a service that we need to consume on premises, we can set up PrivateLink in our Amazon account, as well as set up our Direct Connect or VPN. And because those ENIs, or elastic network interfaces, are routable, we can set up our routers and our permissions to allow traffic to flow back and forth to those ENIs. Another thing to note is that when we're in a situation such as this, the connectivity for PrivateLink is unidirectional. So the unidirectional flow means that it must be initiated by the consumer. The provider cannot reach back in through and gain access to on-prem. So think of it as a stateful one-way door. And to top that off, we can also put security groups on top of each of those interfaces to further control who can gain access to those interfaces and where they can go. It is often a good idea to note that you want to make sure that your provider can actually gain access on the port and on the IPs of those interfaces so they can actually still provide their service. And of course, if you are a provider, you can do the same thing. So again, going back to the manufacturing, say you have programmable logic controllers or PLCs or something that is sending out data, and you want to collect that and send it to somebody, to a customer or someone in the cloud, you can simply do that by setting up a Direct Connect VPN. And our network load balancer, or NLB, has the ability to use an IP address as one of its targets. So it can actually set its target to be whatever you want on-prem, and then with PrivateLink, offer that connectivity to other AWS cloud users over the AWS backbone. Remember, it is a one-way door, so that you have to make sure that when your customers request, you can accept that request and send that back. The other thing, too, is not only is this helpful for our partners and for our customers to provide services to other customers and partners, it is also good for allowing us to give you access to our services on-prem. You may need to consume something that is in the cloud, and we offer PrivateLink for things like Kinesis, Athena, and as I mentioned, S3. And because those PrivateLink endpoints have IP addresses that are local and routable, you can go ahead and set up connectivity that way as well. And there are plenty of services for PrivateLink that are available. There's much more here now on this list. There wouldn't be enough room to list them all, or it would be a big block of text, but I encourage you to go and check out what services you can get through PrivateLink. A couple of things to note about S3. Before, to access S3 through those gateway endpoints, you would actually have to go through something like a squid proxy or a custom solution, which could be quite messy and even charge quite a bit of money because you have to maintain that infrastructure to be able to gain access to S3. But now, because of the PrivateLink endpoint for S3, you can gain direct access from on-prem. Why would you want to do this over your VPN or Direct Connect? Well, because you want to have privacy and you want to have the required speeds that you need to either put or get information out of your S3 buckets. Now, just because we've enabled PrivateLink endpoints doesn't mean that you can't use both the gateway endpoint and the PrivateLink endpoint to go ahead and gain access to your infrastructure. In this example here, you can go ahead and use your local access in your VPC through the gateway endpoint and taking advantage of all of the security and all of the speed there, as well as take advantage of the interface endpoint for S3 over the Direct Connect VPN. You must be careful, though, that your interface endpoint must be set up so that its security or your security group on that endpoint allows for your on-prem to actually get connectivity. And if you need any applications to take advantage of that endpoint, you need to make sure that they're pointing to the right DNS or to the right IP address to gain access. Now, the one thing that I always harp about too, setting up all of these architectures and getting access to AWS from on-prem still requires you to think about infrastructure. Why we do this is because we want to make sure that you can continually improve and get better and better the same way we do, and what we call the improvement cycle. So the first thing you do is you understand the metrics of what you have when you set it up. This will allow you, because you're using infrastructure as code, to go ahead and set up automation. And then from there, you can go and use rapid rollout. And then if you have any trouble, you can go ahead and recover quickly by backing off changes or looking at the differences between the changes. And then your time to recover is lessened. And then you also learn what's going to happen, lessons learned. And then you can basically wrap that in to your cycle. Now, granted, there are pieces of our infrastructure, such as Direct Connect, that still require you to communicate to partners. But we encourage you that anywhere you can, please use infrastructure as code so that it will actually help you recover faster, make adds, moves, and changes faster, and react much better. Thank you very much for attending our session today on hybrid connectivity. My name is James Wenzel, and I hope you have a good day.